In this video, we're diving deep into advanced scaling techniques in Python to enhance your model's performance. By the end, you'll be able to choose and apply the right scaling method for any dataset.
Have you ever wondered why your machine learning models aren't performing as expected? One often overlooked factor could be feature scaling. In this video, we'll explore why scaling is critical in machine learning. Scaling helps in standardizing the range of independent variables or features of data, which ensures that each feature contributes equally to the final model. By the end of this video, you'll have a comprehensive understanding of different scaling techniques and how to apply them in Python to improve your model's performance.
Let's dive into the fundamentals of feature scaling. Feature scaling involves adjusting the range of features in your data. This is essential because many machine learning algorithms work better or converge faster when features are on a similar scale. The benefits of scaling are manifold. It enhances the model's accuracy, ensures faster convergence, and prevents features with higher ranges from dominating the learning process. Common methods include standardization and normalization, each serving different purposes depending on the data's characteristics. Understanding when and how to apply these methods is key to mastering machine learning.
Now, let's compare two popular scaling techniques, standardization and normalization. Standardization rescales data to have a mean of 0 and a standard deviation of 1, making it useful for algorithms that assume Gaussian distribution. Normalization, on the other hand, scales data to fit within a specified range, typically 0 to 1, and is ideal when you want to maintain the relative distances between data points. Choosing between these two depends on the algorithm and the data's distribution. We'll demonstrate these techniques using Python to highlight their applications and differences. Robust scaling is your go-to technique when dealing with data that contains outliers. Unlike other scaling methods, robust scaling uses the median and interquartile range, making it less sensitive to outliers. This is particularly useful in scenarios where outliers could skew the data, such as financial datasets. In this section, we'll explore how robust scaling compares to other methods and demonstrate its implementation in Python. By the end, you'll understand when this technique is most appropriate and how it can lead to more stable models. Min-max scaling is a straightforward yet powerful technique that scales each feature to a given range, typically 0 to 1. This method is particularly beneficial when you want to preserve the relationships between data points while transforming them to a common scale. Min-max scaling is often used in algorithms like neural networks and k-means clustering, where it helps in speeding up the convergence process. In this section, we'll illustrate how min-max scaling works, its advantages over other methods, and how to implement it in Python effectively.
Power transformations are crucial when your data deviates from normality, which can impact the performance of certain algorithms. Techniques like the Box-Cox or Yo-Johnson transformations help in stabilizing variance and achieving a normal distribution. This is vital for algorithms like linear regression or logistic regression that assume a Gaussian distribution. In this block, we'll explore the principles behind power transformations, their practical applications, and how to implement them using Python, ensuring your data is well prepared for modeling. Outliers can significantly skew your data, affecting both the accuracy and efficiency of your models. It's essential to address outliers before or during the scaling process. Various techniques, such as robust scaling, winsorizing, or removing outliers, can be employed to mitigate their impact. In this section, we'll discuss practical strategies for handling outliers, demonstrate how to integrate these with scaling techniques, and provide Python examples using real-world datasets. This will equip you with the tools to refine your data preprocessing workflow effectively.
Scaling is not just a theoretical concept but a practical necessity in real-world datasets. In this segment, we delve into a detailed case study that highlights the challenges and solutions involved in scaling real-world data. We'll examine a dataset, identify scaling needs, apply various techniques, and analyze their impact on model performance. This case study will provide you with insights into how scaling can be effectively implemented in practical scenarios, preparing you to tackle complex datasets with confidence.
Selecting the right scaling technique is crucial for optimizing your model's performance. Several factors influence this choice, including the algorithm you're using, the characteristics of your data, and the presence of outliers. In this segment, we'll explore guidelines and best practices for choosing the appropriate scaling method. We'll discuss how to align your scaling choice with your model's requirements and how to use a trial and error approach to fine-tune your results. By the end, you'll be equipped with a decision-making framework to enhance your data preprocessing strategy.
Let's put theory into practice with a hands-on Python tutorial. We'll explore popular libraries such as scikit-learn and pandas to implement various scaling techniques. This step-by-step guide will walk you through the process of applying standardization, normalization, robust scaling, and more. We'll also cover how to integrate these techniques into data pre-processing pipelines and evaluate their impact on model performance. By the end, you'll have practical coding skills to apply scaling effectively in your projects. Congratulations on mastering feature scaling techniques in Python. We've covered a range of methods, from standardization to power transformations, and explored their applications in real-world scenarios. Remember, choosing the right scaling technique is vital for model success. If you found this video helpful, please like, comment, and share it with others. Subscribe to our channel for more in-depth tutorials, and let us know in the comments what topics you'd like us to cover next. Your feedback helps us create content tailored to your learning needs.